Hi and welcome to Unit 2, Topic 3, Video 18. And in this video, we're going to look at rotations, which I've written there as finally something less trivial. And you might disagree with me, but I think the previous ones were pretty trivial. Rotations is a little bit more complex, but not too bad. And the good thing about rotations is there's a really nice formula on the formula sheet, which you can use to develop or determine any rotation at all. But the question I want to start with is just a kind of leading question is, what happens if we rotate by 90, 180 or 270 anti-clockwise? Now it's important we talk the anti-clockwise because remember, with the exception of navigation and bearings, we always measure angles from the x-axis in an anti-clockwise direction. So we're going to stick with this anti-clockwise idea. If you do a rotation clockwise, then you have to consider it as a negative anti-clockwise rotation. Otherwise that generalized formula won't work. Okay, so step one will be if I rotate this around clockwise there, and hopefully you can see that this will go to this coordinate, which is -4, 1. And then step two, so I'll call this 1. Step 2 is the 180 degrees, which goes around to this coordinate here, which is -1, -4. And step 3 is this rotation here to this coordinate, which is 4, -1. And then we're back to the original with that full rotation. So there's my rotation, my imperfect circle, but the best I could possibly do. And this rotation represents those movements. Now I can develop reasonably quickly a bit of an idea of what these rotations are, and we can have a play around with them. What I get out of this is not super obvious. But to start with, I need to take the original point, which is 1, 4, and I want it to go to -4, 1. So hopefully you can see there's lots of ways I could do it with dilations, etc., but that's not the right approach. The right approach here is to recognize that by doing a rotation, I'm kind of flipping the x and y. So what I'm going to do is I'm going to get rid of the x component here and use a negative y component. So that's a -1. There will give me that -4, and then I've got a 1 there because the x goes down to the y and 0. And the next one I get the same thing, but this time I'm taking 1, 4, the original, to -1, -4, that guy there. And so I'll just do this a little lower so we can see what we're talking about. In this case, I'm just doing -1, 0, 0, -1. That does all the work for me there. And then I've got this last one here, and that is taking 1, 4 to 4, -1. So I've got that movement again. There it is there. And the 4 goes to 4, so 0, 1. The 1 goes to -1, so -1, 0. So you can see a bit of symmetry there. If I don't rotate it at all, it's just basically 1, 0, 0, 1, and then I get those flip overs, which is interesting. They're the three main rotations, 90, 180, and 270. But what if we want to rotate by 57 degrees? That's the tricky bit. You notice here the rotation is always happening around the origin. We'll get to a bit more complexity on that soon. But generally speaking, if we want to rotate by an angle of theta, well then we use this. X dash y dash is equal to cos theta, negative sine theta, cos theta, xy. And does this work above? Well, let's have a think about it. If I want to rotate 90, cos 90 is 0, negative sine 90 is -1, sine 90 is 1, and cos 90 is 0, so I get 0, -1, 1, 0, which is exactly what we had here, 0, -1, 1, 0. So it does work for the one above. And this is what we get here, this 0 degrees. So happy days. This is proven in the text using the formula we'll learn next term. Now I've written this based on what I'm doing in my class. So if you've done Unit 2, Topic 2, which is the trigonometry topic, you can read through this proof if you want to, and it will work. But I often haven't done that already with my class, so the proof requires some double angle formula and stuff like that. So read through the proof if you'd like to. So let's have a look at an example. I want to rotate the isosceles triangle. There's been a bit lazy with the word triangle there. 45 degrees about the origin, given its vertices are 2, 1, 1, 4, and 3, 4. Sketch T and T dash to confirm this rotation. Okay, so the 45 degree is going to be, T is going to be equal to cos 45, negative sine 45, sine 45, cos 45, and that's going to be equal to 1 on root 2, negative 1 on root 2, 1 on root 2, 1 on root 2, and I want to multiply that by the original shape. Now I suspect, if I remember correctly, I'm probably going to need a little bit more room here, so let's just add a bit of room. I'm going to do t times s, I'll call that the shape, and that's going to be equal to 1 on root 2. In fact, I might even take 1 on root 2 out as a common factor. 1 on root 2 there, 1, negative 1, 1, 1. And I'm going to multiply that by the shape, which is 2, 1, 1, 4, 3, 4. So I can do that multiplication now. 1 on root 2, and I get 1, negative 1 gives me 2, minus 1 is 1. 1 minus 4 is negative 3. 3 minus 4 is negative 1. Negative 3. See this function here, 1, 1 just adds these together. 5 and 7. So that's my new shape. Okay, now I can expand the 1 over root 2 in, and I get 3 new coordinates. I can sketch this, but you know, I'm not sketching a number or a diagram of 1 over root 2. So I've prepared one earlier. It looks like this. So there's my original in green. There's my new one in blue. You can see the coordinates match. I've added 2, 1 twice because I've got the line connecting. So it goes 2, 1, 1, 4, 3, 4, and then back to 2, 1. And I've done the same thing down here. My expanded coordinates. So I'll just take a little snippet of that guy and we'll throw it on to the OneNote in the right place. So I'm going to create a bit of space and we've got it there. And then you can have a squiz at it and see how you go. Obviously in the exam it would be a bit trickier. Now I've got a couple of extensions here about how we rotate around, and I know you showed about this, and I had one earlier, you might have spotted in an earlier video. We're going to cover those a little bit later. So they're there for the purpose of my class to have a discussion about them. So there we go. That's our rotation around the origin by 45 degrees. All the best.